Oh, here you going. Right. Today we've got a orange Dark Terror in a funky little bag. Look at that. It's pretty cool. And it's blowing HT fuses. So let's suss it out. There she is. Pretty simple amps. I don't get many of them in here, so they mustn't have any real inherent problems. Let's just suss the fuse out first. There's my multimeter. The other end of the workshop as usual. Alrighty then. So I just got this one in for a quote so far. See what happens. It's blown. Looks blown. Not violently so though. Yep, no continuity. Let's crack her open and have a look. Haven't had the Dark Terror in yet. I've had the whatever the other one is, mini, not micro. Yeah, I don't know. I forget the range names. The one that's like this but not black. Large gourmet salad. It ain't salad till it's gourmet. So has everyone knocked off work yet? How you going, Joe? These are cute little amps. Push-pull with two EL84s, 3 preamp tubes. I think it's yeah, 2 stages, and the second one's a cathode follower, I think, from memory, and the last one's the phase inverter. Solid. You're not really going to take this on the road though. It's a bit sort of low wattage, depending on what you're playing. The dark range, I think, is sort of marketed towards the heavier side of music, so like stoner, and all the stoner rock bands love orange, sludge metal, that kind of thing. And they're good for classic rock too, just balls to the wall rock and roll. They've got that nice smooth Marshall-esque distortion sound, preamp derived. So I'll just have a quick look at these. They're the output tubes, JJ's EL84. The getter flashing still intact. See how it's sort of silvery on top? That is some kind of, I think it's like a tin mercury alloy or something. It's actually, see that little ring in there? Inside there, that's actually coated with it. When they've finished off sucking out all the air that they can, I mean, it's a vacuum tube, but nothing's a complete vacuum, right? They suck out as much air as they can practically with the pump, and then seal that top. There's still a tiny bit of air or some sort of gases left in there, and what they do is they heat up that little ring. Its plating evaporates and condenses on the glass, and that particular metal there sucks up the remainder of the oxygen. Now, if you crack one of these open, slowly that turns white, and that's the mercury or whatever it is oxidizing. It's trying to suck out all oxygen, but because the tube's broken, obviously it can't. So yeah, that's what that little silvery thing is. So if they're white, you know that it's lost its vacuum, so it's broken usually down near the seal here, or sometimes the little nipple breaks off the top while people are handling the amp. So you can see on those two, they've still got vacuum. Hey, Kev, you're my biggest fan. So yeah, I'll just quickly check them for a short. They don't look like they've overheated. If they get really hot, the red paint tends to go like a brown. Something if it goes real bad, like it goes black. It's just the paint burning. Varies on different brands, but you can usually see some evidence on it that it's gotten way too hot. I'll just check for quick shorts. So there should be no connection, at least at low voltage, which is my multimeter, between these pins. So 4 and 5 should be connected. Gotta go upside down. They are, that's the heater, showing about 1 ohm. So that means that the heater should be fine, 1.3 ohm. But between that and any of the other pins, there should be no connection. So just go around and, well, I'll check them first, the heater. Yeah, no connection to any of them. So then we've got, well, there should be no connection between anything except 4 and 5. That was just leads touching. Dutching. Again, so no obvious shorts in that tube. It's pretty rare that happens, especially when there's no other visible damage to the thing. I've had it though. Four and 5. Yeah, that's the heaters, good. Pretty unlikely. Usually what causes the high tension fuse to blow, in my experience, is shorted diodes or a shorted rectifier tube, which does the same thing sort of as the diodes, depending on what amp you got. They can be underrated for the current required. They can just fail for no apparent reason. I think I said in another video, when you look at the specs of diodes, there's an expected failure rate on the data sheet, and it's around 1%, which isn't insignificant. So often it just fails for no apparent reason. It's just something wrong with the die. Oh, it's a tightly packed little unit. Yeah. Caps don't look dramatically wrong or anything like that. That's a bridge rectifier down there. I'll check that there's no voltage floating around this thing first. Go to ground. I'll go from pin 3. from cathode, or I'll just go from ground. Pin 1 of 12AX7, 0 volts. Pin 1 should be connected via anode load resistor. Yep, 0 volts. So there must be a pretty big bleeder on this because it's gone right down to 0. What am I looking at? Pin 7. 0 volts. The other one's hidden under those jacks, but that'll be the same. So there's nothing on the plates. Those caps aren't charged. Just give it a quick visual check. Doesn't seem to be anything burnt. It's got your power voltage selector on the side. That's set at 230, so that wouldn't have blown it. Let's check the mains one as well. He said only the high tension's blown, but I'll just check the mains. Looks intact. Sometimes they look intact and they're not, but that is. So is the spare. Yeah, the annoying part. Removing shit. Just take the preamp tubes out. None of them have got any obvious shit going on. 81. 83, 83, that's ECC 83, otherwise known as 12AX7. So that's just it's got power selection, so I'm not sure how they do that. It looks like all of those, well, the either side of that switch goes down to the power tranny, so I guess that's changing the voltage of the HT between two levels, and that's how it's changing it from supposed 15 to 7 watts. Makes sense? And the output comes there in the red wire, so that's the high tension line. It's coming to there. Just check that cap down in there. Can't get in it. Nah, it's not shorted. Half the traces are on the bottom side of the board, which is a bit annoying. If I knew what I was doing, I'd be able to pick where the dropper resistors are, which is, looks like that. I'll just get my little leads, little pin leads. Put her on diode check. See them? Ow. They really are spiky. You can use them on surface mount gear. Yeah, bridge looks fine too. He did say it's only blowing him every now and then, so I'm wondering if it's either something in the heater circuit or it's running too hot, biased too hot in other words. So, without looking up the schematic, because that's just like cheating, pin 3 of the EL84s, so that's that one there. Pin 3 of both of them should be connected. I think it's cathode bias, this one. No, there's a resistor between them. Watt, 470, 150, 150. Okay. Did I get that right? Oh no, I'm going the wrong way. Yeah, so pin 3 of both the power tubes is connected. And then they have a resistor to ground and a cap, bypass cap to ground. So I'd say that's that one there. It'll be a pretty low voltage cap. There's a 220 mic there. It seems a bit up there, but could be it. Probably that resistor there, which I can't get to. No, can't get to it. Now it's time to check the power rails, see if we've got a short somewhere. Alright, so we've got that red would be the center tap to the output tranny. Oh, sorry, the brown will be brown CT. Right, so that and pin 7, 123 ohms. So that's your screen resistor. 123. Genebri. I don't know, this is getting pretty boring. I think I might sign off and go get a schematic and have a proper look at this thing, instead of just dicking around hoping it jumps out at me. That's funny. It's not going to cause anything, but it's like the hum balance pot is maxed out. Maybe that's where it needs to be. With a really sketchy tranny. No, wrong trace. It's got shit on the other side of the board I'm missing. Yeah, that's reacting properly. So that's the heater wires there. They quick connects? No. They're little things that go to the other side of the board. These are the things I'm talking about. those things. It's funny that they've hardwired some and then they've got connectors in others. Must just be quick to assemble that way. What do I know about mass production? Fuck all, that's what. See. G'day Six, how you doing, mate? Yeah, I've got no problem with how they've mounted the heaters or how they've connected the heaters. I think it's it's smart to keep them off the board. Just these funny little block things, but I guess that just makes it easier to shove them in the factory. It's just funny that the one of them there doesn't have it, and then the other ones do. At least they didn't use those little push-on connectors. That'd be a friggin' nightmare, even worse than quick connects. I don't know. Yeah, those sockets are independent of the chassis, so I can take the board out without undoing those little retainers. That's cool. It's not real cool from a sturdiness perspective, but it's cool from a servicing perspective. Oh, you fucker. Clumsy dickhead. Let's grab those washers before I lose them. Always seem to end up one short, so I bought a bag of them. Take off the knobs. Oh, Jesus. Oh, they're tough. Carly branded caps. Never heard of them. Sounds like a porn star name. Probably don't have to remove the board. Just when stuff's intermittently shorting out, I like to check everything. The last thing I want is to send an amp back and it happens again, and I look like a dickhead, even more than usual anyway. I need to remagnetise my screwdriver. That's better. So you don't like oranges 6? Is there another screw hiding? Yep, there is. Always is. Whoa. Check out the sign-off signature. Interesting. What you'll see. Just disconnect the lamp, the connectors are getting in the way. Oh, for fuck's sake. Are we back? Laptop's battery went dead, I didn't plug it in. Not the smartest cat. Everything's connected to everything. And the board. Ah, they've got these quick connects that have a little catch on them. You've got to squeeze them just in the right spot to get them off. Story of my life. Alright, nothing wrong. Not at first glance, anyway. A little bit of dust on there, but it's pretty good, really. No burn marks. Alright, I'm going to be lazy and see if I can find a schematic on the confuser. Orange Dark Terror. Is that it? Oh, he's orange, one of those nice companies that gives out schematics. Oh no, that's a signature one. Jim Root. What a nickname. Rock of Verve. Tiny Terror. TH30. I'll look up the Jim Root one. It's probably got a similar circuit, just different tone stack or something. View. Image. There we go. Let's look at the power supply first. I wonder if I can get this on the screen. That'd be pretty cool. Capture. I've never done this before. I say that every day. Display capture. Create new. Yes. Whoa. There we go. I don't know how to switch between them. You can see that, eh? Oh, that's awesome. Alright. Let's go to the schematic. Can you see that? Yeah, sweet. Yeah, so here's your power supply. There's the standby switch, switching between two taps. Can you really see that? That's cool as. I'm blown away. I'll go full screen for you. Yeah, so there's your high tension two taps. One at 173 volt, one at 238. So when it's under the full 238, it's coming out at the full 15 watts, or what they say is 15 watts. There's the fuse that's tripping, breaking. So if C30 was short, that would blow straight away. So let's see where C30 is. I've got a feeling that's one I already checked. Yeah, boo. Let's check it again anyway. So I'll just go back to the thingy with the stuff. Video capture. Huh? That one. There we go. Right. Keep going to download schematics, but and like keep a database of them or print them out, put them in here, but I just print them every time. Not very environmentally conscious, I know. Cap is not shorted. I hate it when it's not the easy thing. Alright, so let's go back to this one and have a gaze. Anyone there? Yep. Have a quick gaze. So, goes into the bridge rectifier. Now I checked all of them, they're not short, but again I'll just check again. Which is down there. So that's your bridge. Let me zoom in. Alright, so that's your bridge rectifier there. It's just 4 diodes in a bridge configuration. Now see that, how the 2 outer terminals are plus minus, so that's your DC out. See how it beeps and then it stops? That's just the first cap charging up. It appears to the multimeter as a short circuit the first second or even less that you test it. And then as it charges up, its resistance raises to the point where the continuity tester doesn't pick it up. So that's normal. And the other 2 shouldn't show hack all in standby. As soon as you flick it from standby, it'll show the resistance of the transformer, which is not correct. Oh, because I've taken the fuse out. Dumbass. Fuck. Yeah. So, let's just test the secondary winding. It's showing about 26 ohms, which is about right. It's not showing open circuit or anything dramatic. Yeah, there's something there, but can I zoom in? You got the nice afternoon sun blocking out my vision. So I just spotted there. It's not the issue, but it's not real good on Orange's behalf. See that little lead there? It's like it got bent over in the chopping off process. So one of them comes loose in an amp and it can cause problems. It's pretty subtle though. If it was like that on every second joint, I'd be concerned, but at first glance it looks like the only one. Alright, well, I've got a feeling that it was just biased too hot, but we'll continue checking. Alright, so we'll go back to the circuit. So, this becomes ground, and from that point forward, instead of a line going all the way across, it just shows the same symbol everywhere where it's ground, chassis ground. That's earth connection, like over here. Let me just, I might save this. Oh no, I can do it here. Yeah, so somewhere there's too much current flowing through this from somewhere on this line. So it could be anywhere. So let's keep checking. C26 plus. That is a 220 mic 450 volt. So 220 mic 450, that's its big bugger. Let's check its resistance to ground. Got a nice nice central star groundish point in the middle, which is nice and convenient. So we have, oh, wrong wrong terminal. See, the thing with live videos is it shows how truly dumb I really am. People think I'm smart because I fix stuff. No. So that's showing about 100k, which is probably right. 100k. Well, it's got a 220k in series with it. It's supposed to have anyway. It's showing 66.89. So that would be in series with a bunch of other stuff, but it should be higher than that. So that is that one down there, 49. I'll just pop that out of circuit for a sec to check it. Good if my soldering iron was on. Oh, Gav, it's interesting you say that, mate, because this guy's in a metal band and he downtunes. Interesting. Maybe if I just, well, I guess if he's driving the power amp stage into hard distortion, you're gonna have grid conduction and it could pop. It's not really built for it, being a little choocher. Well, that's interesting. I'll check that resistor because I think that should be reading a touch higher. And then we'll just, that'll be peace of mind, and we'll just fire it up. I'll fire it up on the load and see what kind of current it draws. Coming into the warm weather because I've got to refill my solder sponge every day. Put the water right next to my laptop. That's nice and smart. Being that it's a massive cap, 220 mic, it's hard to take an accurate reading with a multimeter when it's in parallel with it, the resistor that is, because the cap's doing weird shit. I'm sorry if I gross out anyone watching with my loud breathing noises. I only listened to a video the other day and it grossed me out. I've got to turn down the compressor in the camera or something. 213k, that's right. There's nothing worse than a loud breather. just like a loud eater. Well, there doesn't appear to be any shorts, except these ones. I've checked her over, so I'm pretty confident that nothing mechanical has happened. So I might pop her back together and stick her on a load, see what frig's going on. I mean, yeah, these things aren't really designed for full-on gig volume. Anyone that's using them as such is probably going to have some dramas sooner or later. The fact there's weird no-name caps, J-Keck. Where do they come up with these names? And they all have con normally at the end of them, like they're a fucking scam. Jemmy Con, Samwa. They've all got funny names, but yeah. They probably think Brad's a weird name. Kinda is. Haven't heard of anyone calling him Brad, their kid Brad, for the last 20 years. The Vosches back on. Oh fuck. There it goes. Pretty boring stream, really. Probably find nothing wrong with it. I can't charge anything. How you going, Joe? Only just saw your comment, mate. If you're still there. Sorry, not Joe. John. Can't read my own screen. Sweet as. Well, today I'm thinking this is a pretty boring stream, so I might end it here. Put it back together and do a test. And just post up the results, how it went. And blah. Have something more interesting for you soon. It'd be nice to have something that's like fully caught on fire, eh? Something where there's catastrophic disaster inside it. We get to have a bit of fun, like even more than that Messer. I should have the transformer for that tomorrow, I think. So, be able to do the wiring up. Probably won't film all the wiring up of the Messer because that's a pretty tedious process. And I'll forget to talk because when my mind works, my mouth doesn't. But either way, I'll post up the firing it up, testing it. Might even mic it up and do a proper sound test. Got pretty good results just chucking the mic directly into the camera. The built-in compressor in the camera could handle pretty well. I was running it through a desk, a mixing console, and compressed it in there, and the signal came to the camera pretty good. So I might try that again for the mess when I get it back together. We'll go from there. Alright, here I've stitched the Dark Terror back together, tested the bias. It's cathode biased, 150 ohm cathode resistor. Calculated that was running about 94% dissipation on each tube, which is about right for a cathode biased amp, so no big issues there. Let's power up. Here I've got the load, which is one of these wire wound non-inductive resistors. It's 100 watt rated, 8 ohms, more or less. And that's going into the 8 ohm output on the back of the Dark Terror. And off that, I've got the black and white leads, which are going to the multimeter. True RMS. Look, it says so on the label. True RMS meter. Some of the cheap ones aren't. So yeah, that should give us good RMS power output reading. And that's the scope lead, the funky looking one. That's going to the oscilloscope. This thing over here looks a bit washed out on the screen actually. Let me adjust that. That's a bit nicer, isn't it? Maybe. I'll turn the light off when you're looking at that. Looks a bit cooler. So yeah, what I'm going to do is feed it some signal, crank her up, do it on the 15 watt and the 7 watt settings, see what the power output is. So this has got a gain knob there, which is the preamp gain. You crank that up, you can get distortion, and then you've got like the master volume there, which controls how much of the preamp gets to the power amp. So what I'm going to do to make sure it's clean is crank the volume up all the way, and then just bring the gain up till it starts to clip, because then I'm pretty sure that it's going to be just power amp clipping, no preamp distortion. Here's my sketchy rig up here. That's a function generator made in Melbourne back when Australia used to build shit, and that's going to pump out a sine wave at 1 kilohertz, and I'll test it at 400 hertz as well, and we'll take the readings at both and figure out how much power she's putting out. So I'll put you over here. This is where the interesting shit's going on anyway. You can see the meter reading there. It's just picking up background shit at the moment, so it's at 0.7 millivolts average. It sort of averages out over time. You'll see that jump right up as soon as I start feeding signal, and that'll go up roughly proportional to the waveform getting bigger. Let's suss it out. So at the moment I'm on 1 kilohertz. Might write this down. Grab a pen. So 1 kilohertz test. Sine wave, of course. We'll try this on the 15 watt setting first. So click her on, 15 watt, just write it down. Onset of clipping, so that's where the waveform starts to look a bit funky. You see there, it's just coming up. Crank the volume all the way up, then bring the gain up. You can see the waveform getting bigger there. So we're just looking at the oscilloscope, we're just looking for where the tips of the waveform start to flatten off a bit, you see there? Then you get a bit of crossover distortion in the middle as well. So that's what we before the crossover distortion kicks in. That's those funky bits in the middle where it's passing over from one tube to the other. We're just looking for where there's like little nipples on the end start to go flat, and we call that the onset of clipping. And you can see there we're at about 10.5 volts. That's AC, RMS, so average-ish measurement. Probably if you want to know about RMS and average and peak to peak and whatever, there's lots of wicked articles about it online. But what we're looking for our measurement is about there. So we're talking about 10.5 volts. So we just go 10.5. The formula is RMS voltage squared divided by the amount of ohms you're pumping it through. So we're getting about 13.7 watts at that. 15 watt. It's pretty normal. A little bit under, but they tend to overrate stuff a little bit, get a nice round figure. It's never really like that in the real world. So let's try it on the 7 watt setting. I'll just crank that down again. Clicker over. Bring it up again. So onset of clipping for the 7 watt setting, which is the lower plate voltage. Nothing else, just lower plate. Starting to flatten off there. It kicks in a bit quicker, which is understandable. We're about 7.5 probably before you start to sort of detect that it's clipping. 7.5 watts. Alright, let's turn that down. We'll flick it. We'll turn it over to 400 hertz. See how that tiny little output tranny deals with lower frequencies. Right, we're still on the 7 watt setting. 400 hertz. Yes, it does. Sine. Bring her up. You can see the waveform's much bigger there. I'll change the time constant on the scope. Bring her up. Just starting to clip there. About 7.5. So it's not bad, around 400 hertz. Just write that down. 7.5. Right, change that to 15 watts. It's probably going to be the same again. Just starting to click there. 10.5 again. Cool. So that's same at lower frequencies. So just note here as I turn it up, I might just make that a bit wider so you can see the individual wave. Crank it up and you'll start to see the results of the tube not being able to bias itself. It's pushing into probably class B operation there. But there's no evidence of fluttering on the top of the waveform. If you see a bit of fluttering happening up the top there, usually means the power supply caps aren't doing their job. They're struggling. They're not able to back up that spot between the waveforms, and the 50 hertz mains signal starts coming back into it. You probably noticed that. I think I saw it a bit more on the higher frequencies, probably more close to the center of the transformer's frequency response. No, it's not doing it there now. I don't know what I was looking at before. Yeah, that's solid. The caps are good. The crossover distortion is not showing until it's pushing into pretty hard clipping, and it's taking it like a champ. Now, let's have another play. I'll pull the master volume down, and I'll bring up the gain, and you'll see the waveform start to clip. Now that is preamp distortion. I can turn it down. That's getting a bit sketchy there because the scope's probably not triggering properly. That's better. So our level's right down at the moment, but I'm dialing in that distortion with the preamp. So that's your preamp distortion. almost square wave, you know, it pushes it real hard. And as you turn that up, watch the voltage go through the friggin' roof. Goes right up to about 12-13 volts. That's because the average RMS power of a square wave is higher than a sine wave. Now I saw some guy quoting his amp was so great today on a Facebook group about tube amp building, because he was measuring it with a square wave. Like, his power readings were right, but it's not the way we measure stuff. We say watts RMS, 1 kilohertz sine. If you take measurements and you don't specify what conditions they were taken under, your measurements don't mean fuck all. It's like buying a hi-fi from Dick Smith back when they were open. Oh, it's a 5,000 watt thing, but you look at the power input on the mains input and it's 100, like, you know, 30 watts max. That doesn't lie. You can't make power out of nothing. Well, as many people on YouTube think you can. So the power going in is a lot more than the power coming out. So if you see a 1,000 watt amp supposed on the front and it only draws 30 watts from the mains, you can bet that's about a 15 watt amp total. So yeah, anyway, I thought you might want to have a look at that. This amp is fine. I reckon it's probably just been pushed real hard into clipping, and that punishes the output tubes a bit. I wonder if we can see a bit of grid conduction happening here if I punish it. Alright, see how good the camera is. Oh, you almost can see that. That's pretty cool. So, oh, it's kind of, I don't know if we're going to be able to make it out, but if you look through, there's a little vent in the tubes, right sort of there, and as I crank this up, you might start to see a glow happening in there. No, not really. I can see it, but you can't see it on film. Show my age. Yeah, that's the grid starting to conduct, and they don't really like doing that all day long. So if you've got an amp like this and you're pushing the power amp into hard distortion, especially when you've got a lot of distortion happening in the preamp already, it's probably time for a bigger amp. They don't really like it all day long. And these things are built down to a price. They're good, but they're built down to a price, so they don't put massively over-spec components in there. So get a bigger amp. I think this one's fine. It just doesn't like mad down-tuned metal head punishment. So yeah, off she goes. Anyway, thanks again for watching. Take it easy.